Welcome back to Computer Science classes, Database Management System, Session 57, Properties of Transaction and Transaction States, which comes under Chapter 9, Transaction Processing Concept. So here first we'll discuss about properties of transaction or transaction properties. So here DBMS has to maintain the following properties of transaction. So DBMS has to maintain the following properties of transaction is nothing but ACID. ACID. What is meant by ACID? Atomicity, consistency, isolation, and durability. These four are called properties of transaction. These four are called properties of transaction. So here, what is meant by atomicity? First one, atomicity. So what is my atomicity means? A transaction is an automatic unit of processing, and it either has to be performed in its entirely or not at all. A transaction is an automatic unit of processing, and it either has to perform or in its entirely or not at all. So that is called as atomicity. So like here automatic unit of automatic unit of processing, and it either has to be performed or in its entirely or not all. That is called as atomicity. So like it is a one of the automatic processing. So suppose it ensured that either all the database operation in a transactions are executed or none are executed. So what is meant by atomicity here? A transaction is an automatic unit of processing, and it is either performed in its entirely or not performed at all. It ensured that either all the database operations in a transaction are executed or none are executed. So second one, consistency. So what is meant by consistency? Preservation. So consistency is also called a consistency preservation. Okay, a transaction means a successful execution or transaction of a transaction must take consistent database state. A successful execution of a transaction must take a consistent database state. It contains consistent database state. So like a transaction is said to be consistency preserving if it's a complete execution takes the database from one consistent state to another. So a transaction is said to be consistency preserving if its complete execution takes the database from one consistent state to another. That is called as consistency preservation. Okay, third one is called isolation. What is meant by isolation? A transaction must not make its modifications. A transaction must not make its modification visible to other transactions. Visible to other transactions until it is committed. It means at the time of one transaction is running while same time other transaction is going on. It's nothing but concurrency control. Isolation is nothing but concurrency control, because transaction must not make its modification visible to other transactions until it is committed. It means at the time of one transaction is running while same time other transaction is going on. There is nothing but concurrency control. Next one is here isolation. The execution of transactions should not be interleaved with by any other transactions. Any other transaction executing concurrently. It should appear as though it is being executed in isolation. It should appear as it is being executed in isolation. This ensures that each transaction appears to execute isolation from other transaction, even through hundreds of transactions may be executing concurrently. So hundreds of transactions executed concurrently. So even though hundreds of transactions may be executing concurrently, that is called as isolation. Next, durability is nothing but permanency. Durability is nothing but permanency. Once a transaction is committed, its changes. These changes must never get lost due to system failures. Once a transaction is committed, its changes. These changes must never get lost due to system failures. Once a transaction is committed, its changes. These changes must never get lost due to system failures. So these are the 5 properties, desirable properties of transaction. So this is called ACID. The properties are called ACID. So one is called atomicity. So what is meant by atomicity? And transaction is an atomic unit of processing. Atomic unit of processing, and it either has to be performed in its entirely or not at all. Consistency means what? A successful execution of transaction must take a consistent database state. Next, isolation means what? A transaction must not take its modifications visible to other transactions until it is committed. It means that the one time of one transaction is running while same time other transaction is going on is nothing but concurrency control. Durability. Once a transaction is committed, its changes. These changes must never get lost due to system failures. That is called as transaction. So next, why recovery is needed for transaction? What is the use of recovery is needed for transaction? We require recovery is very important here. Schedules and recovery is very important because recoverability is not there in transaction, automatically it got some exceptions or error. So like transactions submitted for execution. So whenever transaction submitted execution, so automatically the compiler or exception handling methods will be generates errors. So here the recovery is very important here. Dbms is responsible for making sure that either all operation in transactions are completed successfully and the changes is recorded permanent in the database. So like all operation in transactions are completed successfully and the changes is recorded permanent in database. The DBMS must not permit some operations of a transaction. Here transaction is nothing but T to apply to the database while others of T are not. It will cause inconsistency. It will cost is nothing but inconsistency. So like why recovery is needed? Because transactions submitted or execution, DBMS is responsible for making sure that either all operations in transactions are completed successfully and the changes is recorded permanently in the database. The DBMS must not permit some operations of a transaction T to be applied to the database while others of are not. It will cause inconsistency. So why after completion of recovery we can take some information related to recoverability. So when transactions are executed concurrently in an interleaved fashion, then the order of execution of operation from the various transactions is known as schedule or history. So when transactions are executing concurrently in an interleaved fashion, then the order of execution of operations from the various transactions is known as schedule or history. For example, a schedule of S of n transactions, T1 and T2 n, Tn, number of transactions are there, is an ordering of the operations of the transactions subject to the constraint that for each transaction Ti, that participants in S, the operations of Ti in S must appear in the same order which they occur in Ti. Fine. The transaction operations means the transaction operations that are required for recovery and concurrently control or read item, write item, commit and abort. Consider taking an example here, S of A colon R1 of X semicolon R2 of X semicolon W1 of X semicolon R1 of Y semicolon W2 of X semicolon W1 of X. Consider the another schedule SB colon R1 of X semicolon W1 of X semicolon R2 of X semicolon W2 of X semicolon R1 of y semicolon A1. So like two operations in scheduling are said to be conflict if they satisfy all three of the following conditions. So what are the conditions which occurs in transaction? They belong to different transactions. They access the same item X. At least one of the operations is a right item. So these conditions are very important here. They belong to different transaction. They access the same item of X. At least one of the operations is a right item. So that is called as transaction. Okay. So next, why concurrency control is needed? When the several problems can occur when concurrently transactions executed in uncontrolled manner. So in this time, the last update problem. We can last the update problem. Next, temporary update or dirty read problem. Second one. So incorrect summary problem and the media failure. So like why concurrent control is required? Several problems can occur when concurrent transactions execute in an uncontrolled manner. The one is the last update problem, the temporary update or dirty read problem, the incorrect summary problem, and the fourth one is called as media failure. Transaction failures can be a transaction or system error. Transaction failures can be a transaction or system error. So next, the very important topic is transaction states. So what are the transaction state? What is meant by transaction state? Why we can use transaction state? And what are the protocols are used in transaction states? So these are the very important here. So what is meant by transaction state? So first, we learn what is meant by transaction state. A transaction is any one execution of a user program in a DBMS. A transaction moves through various types of execution states. Because a failure occurs, transactions are broken up into several states. So okay, what is meant by transaction states here? A transaction is any one execution of user program in a DBMS. It's nothing but transaction is any one execution of user program in a DBMS. A transaction moves through various types of execution states. Because the failure occurs, transactions are broken up into several states. So like what are the states? Like a transaction moves through various execution states. That is always moves various execution states, not only for one state, that will be moves through various execution states. This can be explained with a state transition diagram. So what is meant by state transition diagram? One diagram is there. So that diagram shows how the transactions will be moved. So like here, first we can begin the transaction. Already some operations and transaction. We can begin the transaction and that will be active. Sometimes that abort, when abort is going to failure, so then it is partially committed. So and then we can use some commit operations. Suppose committed, so until automatically we end the transaction. Whenever we end the transaction, automatically the whole transaction is going to terminate it. Okay, so this diagram shows how the transactions will be terminated with the help of transaction state. So first begin transaction is there, active is going. So when it's not working properly, it is aborted. Abort is nothing but transaction is going to failure. So once again the abort is open, automatically partially committed. Sometimes it occurs problems, once again that is going to failure. Next automatically that goes for commit, so that is committed. So all the operations will be completed, all the transactions will be completed. So then automatically that ends the transaction. That what is meant by end the transaction is nothing but the whole transaction is going to terminate it. So that is called as transaction state transition diagram or state transaction diagram. So here, suppose if you are occurs any problems, otherwise if your transaction are broken up into several status, so that status tells the one is called active state. So what are the states are there? The one is called active state. So what is meant by active state here? The transactions are going to very active. Okay, active state, the transactions are going to active. When execution begins, a transaction goes into active state. Okay, when execution begins, the transaction is going to active state. Okay, the transaction goes to, and when execution begins, a transaction goes to into an active state. In this state, a transaction can issue, read and write operations. So this is very important here. So when an execution begins, a transaction goes to an active state. In this state, a transaction can issue, read and write operation. So what are the operations here? Recorded, read and write operations will be recorded in active state. Okay, fine. So second one is called partially committed state. Partially committed state. So here what is meant by committed state? Partial committed state means what? When transaction ends, it moves to the partially committed state. When transaction ends, it moves to the partially committed state. Automatically that will be moves to the partially committed state. So like some recovery protocol should ensure that a system failures will not result in an inability to record the changes of the transaction permanently. So that is called as partially committed state. So when the transaction ends, it moves to the partially committed state. Some recovery protocols should ensure that a system failures will not result in an inability to record the changes of the transaction permanently. So that is called as partially committed state. Okay, so automatically that will be hence the transaction ends, automatically partially committed state will be moves, because some recovery protocols are there, some system failures are there, so will not result. So it is inability to record, it is very inable to changes, it is not stored in permanently, so automatically a partially committed state will be generated. The third one is called failed state. So what is meant by failed state? So automatically the failed state that will represent abort state. What is meant by abort or failed state is nothing but closed. Means if any of the checks fails, or if a transaction is aborted during its active state. So if any of the checks fails, or if a transaction is aborted during its active state, a transaction can go to the failed state. So in this time, that particular transaction is going to failed state, because the failed state is one of the state, one step. The steps will be checks fails, or if any one of the checks fails, or if a transaction is aborted. So when active state is going on, automatically the transaction is going to aborted. So then we will represent, oh, it is failed state. That is called as the transaction is going to failed. Then the transaction has to be rolled back to undo the effect of write operations on the database. Then the transaction has to be rolled back to undo the effect of write operations on the database. Next, committed state. Aborted state is something but failed state, it's okay, no problem. Committed state. So what it means by committed state? When this check is successful, when this check is successful, the transaction is said to have reached its commit point. When this check is successful, the transaction is said to have reached its commit point and enters the committed state. Okay, when this check is successful, the transaction is said to have reached its commit point and enters the committed state. Automatically that will be transaction is going to check is successful, automatically that is enter into committed state. Once a transaction is committed, it has concluded its execution successfully and all its changes must be recorded permanently in the data. Once again, once a transaction is committed, it is in committed state, it has concluded its execution successfully and all its changes must be recorded permanently in the database. Automatically this type of successfully execution are recorded or permanently recorded. Automatically these are permanently recorded in the database. The database means a collection of logically related data. Okay, so this is called as committed state. Next, the last one is called terminated state. So what is meant by terminated state? The terminated state corresponds to the transaction leaving the system. The terminated state corresponds to the transaction leaving the system. The terminated state corresponds to the transaction leaving the system. Automatically that will be in the system. The transaction information that is maintained in the system tables is removed when the transaction terminates. So here terminate states is nothing but the whole program is going to stop. The transaction is leaving from the outside. The transaction is going to end. It's nothing but end is nothing but that the whole transaction is going to close. So that represents the terminate state corresponds to the transaction leaving the system. The transaction information that is maintained in the system tables as removed when the transaction terminates. So that is called as the transaction can have states. What are the states of transaction? One is called active state, partially committed state, failed state, committed state, aborted state, terminated state. These are all the states of transaction. What is meant by active state? When execution begins and transaction goes into an active state. In this state, a transaction can issue read and write operations. Okay, that is called as active state. What is partially committed state? When the transaction ends, it moves to the partially committed state. Some recovery protocol should be ensure that a system failure will not result in an inability to record the changes of the transaction permanently. That is called as partially committed. Committed state means what? When this check is successful, the transaction is said to have reached its commit point and enters the committed state. Once a transaction is committed, it has concluded its execution successfully and all its changes must be recorded permanently in the database. Failed state. If any of the checks fails or if a transaction is aborted during its active state, a transaction can go to the failed state. So in this time, the transaction has to be rolled back to undo the effect of its write operations on the database. The last one is called terminated state. The terminated state corresponds to the transaction leaving the system. Automatically corresponds to the transaction leaving the system. The transaction information that is maintained in the system tables is removed when the system transaction terminates. Automatically here the whole transaction is going to halted or stopped or terminated. The whole transaction is going to halted or terminated. So this is called as terminate state. So then sometimes we have protocols used in concurrency control. So what are the protocols? There are 3 protocols we can use concurrency control. One is called read phase, second one is called validation phase, and third one is called write phase. So what are the protocols used in concurrency control means there are 3 protocols we can use in concurrency control: read phase, validation phase, and write phase. So these are all the protocols used in concurrency control. Okay, thank you very much. I will see you in next session.